Well, welcome everybody to the day 2 of the USC Symposium on AI with Common Sense. So today we have the second half of the activities that we planned. So yesterday we've covered the sessions on common sense reasoning and common sense knowledge, and we had a keynote by Tomer Ullman. Today we go to the second half of common sense for creativity, common sense in AI agents and robots, and then we will end with a panel on artificial general intelligence and common sense. So without further ado, I would like to introduce the chair of the first session, Kaliroy Jurgila, who's a research associate professor of computer science and a research lead at the Institute for Creative Technologies of the Viterbi School of Engineering.
Thanks, Philip, very much for the introduction. So today we have 4 speakers. Each speaker is going to talk for about 8 minutes, and then at the end of the session, we'll have questions. So in the meantime, if you have any questions, please post them in the Q&A window. And our first speaker today is Mayank Kejriwal, who is a research assistant professor of industrial and systems engineering, and he's also a research team lead at the Information Sciences Institute. And Mayank is going to talk about generating new ideas. So Mayank, it's your turn.
All right, thank you for the introduction. All right, so let's go to the next slide and jump right into it. So I want to begin with the word idea, and it might seem it's a very simple word. You can see here on the left-hand side, the dictionary classifies it as an elementary level concept, with 6 senses. But it turns out that the question of what is an idea is actually a very complicated question that philosophers have thought about for a very long time. The one I like to cite is René Descartes, who classified ideas into 3 different categories. He felt that ideas like God, for example, were innate, we're born with them. Adventitious are things that we discover, and invented by me are basically fictional ideas, like a hippogriff or a hydra or something like that. So, next slide. So we need to narrow down what we mean by an idea, to not go down the rabbit hole, as interesting as it might be. And so our view in this talk, this very brief talk, is that an idea is the recognition, perhaps at an intuitive level, of a novel solution to a challenging problem. So this is certainly one of the senses of the idea, but it's not the only one. So I just want to clarify that. And the article that really clarifies what we mean by this is this one in Scientific American Observations, which is where do ideas come from, and what he says here is basically the first bullet point. And we're not going to look at the others, such as creative prompts or all of that. I think it's very interesting, but it has some issues that require much longer treatment than what we can give it in our current research. Next slide. So we're in a very exciting time for AI, and there are some really exciting pieces of work that just came out in the community of modern AI generating an idea of the kind that I mentioned just now. This paper in Nature, some of you might have heard about it, just sort of came out from DeepMind, where they found that they can help mathematicians, with AI. They can give them ideas that might seem unintuitive initially, but then it turns out that you can actually solve very complicated math theorems where the AI gives you the idea of how to solve it. So this was really exciting work to see, and it's the kind of thing that we are talking about. Next slide. And yet, it just seems like there are really simple things sometimes that we are able to do, but that's difficult for AIs to do. So here's this came out in Quanta, where it turns out that the the AIs can have a hard time fundamentally distinguishing whether two things are the same or not. This is something I also worked on in my PhD thesis, so I sympathize with the problem. So even figuring out whether two things are the same or not can be flummoxing for the AI. So there's still a disconnect somehow between what we can intuitively do and what the AI can intuitively do. Next slide. So given all of this, there are several research questions that we're addressing, and I'll just go very briefly into our work on one of them today. But I just want to state what the questions are to give you a sense of what we are interested in from a research standpoint. So given that we want to communicate a problem to an AI using natural language, and we want the AI to generate solutions to the problem in natural language, and which is our definition of an idea, we want to first know how good are current language representation models that have really been doing well on a lot of problems at idea generation, and how do we measure their capacity for doing so. This is different from normal problems like question answering or those kinds of problems, because we want to know, can the model give us an idea in response to a problem, and how do we know that the idea is good? So this question I will not actually be going into. This is an interesting question. We are working on this. I can take questions on this, but I won't be going into this. And the second one that I'll briefly cover in a couple of slides is what features must an AI in general, not just a language model, have to serve effectively as an idea generator. Next slide. So to answer this second question, there's this DARPA program that we have been working on for 2 years now, and with 2 more years hopefully left to go. And the research is called a Gnome, or Generating Novelty in Open World Multi-Agent Environments. And I'd like to just point you to the underlined section of the program description, which is that intelligent machines need to graduate from closed world problem solving within confined boundaries to open world challenges characterized by fluid and novel situations. I'll just give one very simple example. Let's say that you're playing chess. We know that we can get superhuman performance in chess at this point. And now, all of a sudden, I say that, okay, the goal is not to checkmate the king. The goal is to take both rooks. The first player to take both rooks will win the game. Now, if you ask a human to actually modify their strategy, they may not be optimal, but they don't need to actually go and read the entire manual to figure out how to play that game. Right? They can adapt very quickly in a game or two. They will just know how to play the game. They have a deep understanding of the fundamentals of chess that they can actually modify. But the AI, can an AI agent generate strategic ideas on the fly for responding to the novelty without going and self-training, 30 million times? So that's the question we are addressing. Next slide, and I'm almost done. So why is Gnome unique? Well, the first thing is that it's one of the first simulators that treats novelty as a first-class citizen. So in fact, we implemented the game of Monopoly because it's a very messy game. It has stochastic elements in it. It's multiplayer. And Gnome implements a novelty firewall, which means that we can introduce novelties independently of the team that is building the agent. So this took more than a year of work to make sure that there's one team that develops the novelty, so the problem, and there's an independent team that has to develop the AI that will then generate ideas when presented with the problem. So there's a novelty firewall, which is very unique and exciting in this program. And we have unique metrics to measure the strategic ideas generation. And then finally, for the validation, we have in fact shown that there are 4 independent teams and institutions outside USC that have developed agents that can be evaluated using Gnome. Next slide. If you're more interested, we are organizing a Tripoli AI Spring Symposium in 2022. The call for people has closed. We received out of all the symposia, we had the maximum amount of submissions, more than 30% of the submissions in all the symposia in spring, Tripoli AI. So we're very excited about that because people are interested in this. And we also published a journal article on this, and we had a Murex demo that is still online on our website. So plenty of resources, and for those who are interested, we do hope you will come to the symposium. We will organize it in a hybrid format. Next slide. And I think, yeah, so with that, I will just conclude by saying that we are, the idea of what is novelty, what constitutes a novel problem is a very interesting issue that is at the boundary of philosophy and computer science. And it's something that we are having a very, we're struggling with, but in a good way, because it's really getting us deep into what is novel and what is a novel problem versus just another, problem that is from a distribution you have seen before. So it's an exciting time because it's to me, it's the boundary. It's crossing, it's blurring the boundaries between several areas. And I think we're going to see more of this as we move forward.
So thanks very much, Mayank. And now we have our second speaker, who is Fred Morstatter, who's going to talk about biases in common sense. And Fred is a research assistant professor at the computer science department and also a research scientist at ISI.
All right, yeah, I'm Fred Morstatter. I'm talking about biases in common sense. So I invite you to think about a world where AI works for everybody equally, no matter their background. Unfortunately, we're not there yet. And the reason why is because these AI systems reflect human biases because they're trained on human-generated data. And until we fully understand and address these biases, we're not going to achieve that dream. Next slide, please. So most of the work I'm going to talk about today comes from a paper we recently published in EMNLP. I worked on this with Jay Pujara, Shang Ren, and Aram Galstian. But special credit goes to the PhD students who led this work, Nina Ray Marabi and Paige Wu. Next slide. So what we're doing is we're attempting to address exactly this problem. We want to investigate harms in common sense knowledge resources and the tasks that run upon them. A lot of definitions of common sense have been proposed the last couple of days. The one we're working off is facts about the world that every human is expected to know. And the key word there is facts, right? We want facts. We don't want stereotypes. We don't want biases in terms of prejudice or favoritism. So some examples are shown there at the bottom. These examples come directly from ConceptNet, which is a very widely used common sense knowledge base. On the left there, you see fish are capable of swimming. Okay, great. That sounds like a fact to me. On the right, we see a politician is capable of telling lies. And of course, that's true, but it's true for everyone. And for us to cast this aspersion at only politicians is not fair. And it's going to cause models built upon them to make less fair predictions for that particular group. Why? Why do these sources have these biases? Well, if you attended Yolanda's talk yesterday, you know that these come from human data, often from crowdsourcing. And because it's from humans, it's going to reflect their biases, it's going to contain their biases, but which ones and how much we want to see. Next slide. So here we're looking at particularly prejudice and favoritism. The harms that we are studying are overgeneralization, which is again that prejudice or favoritism. The disparity in overgeneralization, so how different individuals or groups are represented in terms of that overgeneralization, and the disparity in frequency. So it's really not great if one type of individual or group has a ton of rules while another has very few, because the AI system will do better for them. Next slide, please. All right, so what we did to this end is we looked at the sentiment of the tuples in ConceptNet and regard. So if you want to learn more about how we did this, I'll turn you over to the paper. If you're not familiar with regard, I'll just tell you that it's kind of a more precise version of sentiment analysis. I think that's good enough for this talk. So we computed sentiment and regard for all the tuples in different groups. There on the left, you can see one group, one type of group, which is profession. You can see that, so for example, CEOs have a lot of positive tuples, whereas in very few negative ones, whereas performing artists and judges have many negative ones and very few positive ones. Zooming out to look at other groups, there on the right, you can see that this goes beyond just profession. It's contained in religion, gender, and national origin as well. Next slide. So again, remember, just because these biases exist in the data, we need to make sure that they actually exist in the predictions made upon models trained on that data as well. So we took one example, which is Comet. Actually, there are two examples in the paper, but here we're talking about Comet. Comet is a knowledge completion or generation model. So it's trained on GPT and then ConceptNet. And then what it tries to do is it tries to predict additional tuples in the knowledge base. So what we did is we looked at the predictions from Comet. We ran that same approach, and we found that the same biases exist in the predictions made by ConceptNet. In fact, next slide, what we found is that those biases are actually amplified by the algorithm. And this is a pretty common finding in fairness research, right? So these algorithms don't just contain those biases, they actually amplify them. And here it's pretty pronounced. You can see the y-axis totally different. So the raw data, it ends at about 25. The predictions end at about 50. And just in general, it's much, much worse than it is on the raw data. So this is really not good, and it's going to create biases and exacerbate them for certain groups. Next slide. So switching gears a bit, what we're trying to do now is we're trying to debias these models. We've spent particular care to Comet itself. So this is a recent CKids project that I did with Philip, Nina, and a bunch of talented master's students, where we're trying to understand where the bias comes from. So we know that there's bias in ConceptNet, we measured it, but ConceptNet isn't the only thing at play here. There are also other language models that are being used in tandem with ConceptNet to make these predictions. And we want to disentangle where those biases are coming from. So what we did is we varied the language model. You can see on the left there, GPT-2 and 2 flavors of T5. And we also varied the common sense knowledge base. So we looked at Wikidata as well as ConceptNet in order to better understand where these biases are coming from. Next slide. So some takeaways from this, we actually found that Wikidata shows more overgeneralization in the origin and profession categories than ConceptNet. And curiously, the outliers are different between T5 small and T5 base. It's kind of unexpected. You'd think that they would be about the same, but they're not. T5 small is there on the left. You can see it's more biased towards Crimeans, Colombians. And there on the right, the outliers are Iranians, and so on and so forth. All right, next slide. So just to conclude real quick, common sense knowledge bases do in fact reflect human bias. We proposed and executed a way to measure that. These biases are actually amplified in the models trained upon them, which really shows the need that we need to kind of like fix these biases. And biases can be introduced at multiple steps in the pipeline. So what we're working on now is how to disentangle these biases and to kind of fuse multiple data sets to overcome that bias. So there are a lot of data sets out there. Hopefully by combining them, we'll be able to do better than what we have now. Thank you.
Thanks very much, Fred. So our next speaker is Jay Pujara, who is going to talk about explaining stories and dialogues. Jay is the director of the Center on Knowledge Graphs at ISI, and also he's a research assistant professor at the Computer Science Department of USC.
Okay. Thanks for that introduction. So I'm going to talk about explaining stories and dialogue. Next slide. So imagine a world where an AI could read your mind. And the funny thing is, when I was an undergrad 20 years ago, I was trying to do this with fMRI scans. But I'm going to tell you today about AIs that can read your mind without an fMRI scanner. And the really interesting thing, next slide, is that we are all mind readers. When we have a conversation, we're doing this amazing thing where we hear what the other person says, and then we align that with the knowledge in our head in order to make inferences and understand what they're doing. And so every day we're doing some form of mind reading in order to actually understand each other. And so underlying that is this process called grounding, where we reach a mutual set of beliefs and knowledge between two participants. And this makes dialogues a very interesting place to understand how AIs not only acquire common sense, but how they use it. Next slide. So over the last year, we've done a number of projects to create a more human-like approach to AI communication. And in that human-like approach, we want to mirror this process of making inferences about what is being said. And so in order to do that, we want to take background knowledge such as common sense, something that we all have, and build that into the dialogue response generation model. So an AI can respond to a thing you said, just like a human would. Next slide. So the first step we did was there are many dialogue data sets, but not all of them exhibit common sense. So what we wanted to do is take these data sets and create a new corpus that is really focused on common sense and dialogue. And so we used ConceptNet and other common sense knowledge graphs to find concepts that exist in these dialogues and a common sense relationship between something one participant said and the next thing that was a response. And so you can see here an example where somebody says, I'm sleepy, I can hardly keep my eyes open. And the AI or the dialogue has, why don't you go to bed? And we know this is a common sense suggestion because go to bed when you're sleepy. Next slide. So once we had this data set, we wanted to determine whether the existing models out there are able to show this type of common sense. And we looked at two different problems. The first is attribution, where we have some sort of dialogue history, and then we see a response. And we ask the AI, why did that person say that? And the second is inference probing, where we show the history and an explanation, and we ask the system, what do you think the system will respond? Next slide. And so if we go back to that picture, you can see on the right that attribution probing is this link between the response and the explanation, and inference probing is this link between the explanation and the response. And in the example on the left, the realtor says, today is your lucky day, Casey. And Casey says, what? What do you mean? Realtor says, I found a buyer for your house. And Casey says, I'm so happy. And so the reason this makes sense is because the buyer for the house is something that Casey wants, and he's happy that this outcome had a good result. So these are the sorts of two different outputs that we are hoping to have. Next. So to test models, what we did is we gave them the correct answer, the correct explanation that we generated, and we gave them these corrupted explanations. There were logical corruptions where we swapped cause and effect, where we just picked some random cause or effect or random common sense triple, or we negated it. And then we had complete corruptions. And these are just nonsense. We take all the words and we shuffle them in random order, or we read them in backwards order, or we just drop a bunch of words. And so these are things where you can't even make sense of it. And we wanted to know, can the model tell something that's a good explanation from a bad explanation? And what we'd expect is that the models will be able to really seek out the complete corruptions, but the logical corruptions will be a bit harder. Next slide. But what we found was actually really surprising. The models, as we expected, aren't really great at the common sense. You can see their accuracy of picking out the right explanation is around 60%. But they're not actually that great at even the complete corruptions. They're only at 80% for things that look like gibberish, and many models are closer to 50. And even if we teach them how to pick out good explanations, they don't do much better. But humans are really good at this. So that gives us some ammunition to say, this is a really interesting research question. How do we solve it? Next slide. So what we'd like to do is build a better dialogue model. And what we're going to allow the dialogue model to do is talk to itself. And so this is recent work that's under review. And what the idea is that we're going to have a dialogue model produce and materialize a set of inferences and call that self-talk. And then we're going to try and make a response using those inferences. Next slide. Next slide. So here's some examples. If you have the prompt, I need to buy some flowers for my wife, and you have the AI model might think, oh, buying something needs money, and then respond, how much money do you want to spend? Or it might think, hey, the outcome of buying might be giving. So what kind of flowers are you going to give them? But it also comes up with things that are incorrect, like the opposite of buy is sell, and it says, let's sell some flowers, which doesn't make sense. So this is sort of an interesting set of examples. Next slide. That we've seen. But ultimately, when we look at the results, sort of astonishingly, this approach does really well. The dark purple bars are our system, think before speak. And you can see that it outperforms all of the other dialogue models that are not using this, even ones that retrieve knowledge from something like Comet or ConceptNet. And in some cases, we've actually trained response generation models using this knowledge, using the correct response, and we still do better. And so this is a really great result to say, actually modeling this process of inferences allows better response generation using less training data, because not all dialogues have common sense. And then the last thing I'll point out is that the slide on the very right is when we train two different models, the thinking model and the speaking model. And that doesn't do well at all. And that means that actually the thinking and speaking are happening in the same process using the same approach. And I think that's actually really interesting. So very quickly, next slide. I'm going to talk about one other project, which is common sense axioms for story explanation. And this has a similarity to what we're doing with dialogue, where we have some set of axioms or common sense knowledge that makes a story, that allows the story to make sense. And so we're going to formulate that as a set of axioms and knowledge that, when combined, provide an explanation for why a story makes sense. And the great thing is that once you have these axioms and knowledge, you can put them together to make new stories. So in this example, there's a story about Ben who wants to go fishing, but it turns out he doesn't like fishing, so they go watch a movie instead. And what we need to know is that fishing and movies are both activities that you could do under substitutions. Next slide. And so, to kind of connect the dots, we have 120,000 stories that we've created using this approach for things like unmet expectations, substitutions, modifications, and they have this knowledge graph on the bottom and a set of axioms on the top, and we can put them together to both explain stories and generate new stories. And with that, I'll end my talk and just say, we are at a place where AIs can read minds, and the way they're going to do it is through this use of thinking and introspection that we as humans do, and that's an exciting time to be in common sense and in AI. Thanks.
Thanks, Jay. And the last speaker of this session is Emmanuel Johnson, who's going to talk about negotiating agents. And Emmanuel is a postdoctoral research associate at ISI. So it's Emmanuel, you can start. Thank you.
Yes. Hello, everyone. For some reason, it looks like my camera is disabled, so apologize for that. Today, I'm going to be talking about negotiating agents. Next slide. Here we go. All right, so imagine a future where humans are better equipped to negotiate win-win deals. And so this could be through agents that support us during the negotiation and provide critical resources that helps us better negotiate, or AI agents that is able to help train humans to negotiate. In addition to that, we can, for those who may not want to negotiate, imagine if we could build these AI agents that could act as our proxy. So you specify the term of the deal that you want, and then you're able to send this agent off to negotiate on your behalf. Next slide. Now, before I get into how this will work and what we need to make this work, let's begin by first defining what a negotiation is. Generally speaking, we view negotiation as any interactions where you have two or more parties who must decide how best to split up a set of resources. So it could be in a job negotiation where you're trying to decide which job you want based on what salary they offer, or it could be in a geopolitical context where you have countries trying to decide how to split up various resources. And so oftentimes you may either have a win-win scenario where both parties get what they want, or it could be a zero-sum game where one person wins at the expense of another. Next slide. And the reason why this is important to begin to explore improving human negotiation abilities is that, one, we all negotiate on a daily basis, but we find that people aren't very good negotiators. For example, when it comes to salary negotiation, we find a recent survey by Glassdoor showed that 60% of new hires don't even negotiate their salary, and that can affect future earning potential. And beyond salary negotiation, poor negotiation skills can have detrimental effect. For example, most court cases are handled, 90% of court cases are handled through negotiation. And so poor negotiation ability means you are ineffective in settling these court cases. And there's also some geopolitical consequences as well. Next slide. So in order for us to make this future possible where humans are better equipped to negotiate, or for for us to have agents negotiate on our behalf, essentially there's three things we need to do. One, we need to define a set of principles that allow agents to reason about a negotiation and determine whether or not they are doing well. Also, secondly, we need methods that enables agents to diagnose errors that other negotiators may make, as well as errors that it may make in a negotiation. And lastly, we need agents that can interact more naturally with humans. In the case of preparing humans to be better negotiators, these agents could serve as training partners, or they can negotiate on our behalf. Next slide. And so to make this possible, the first thing we need is a set of principles that define what a good negotiation is. And there's quite a good bit of work done in both the psychology and the business space that lays out a number of principles of good negotiation. And these tend to fall into two categories: the value claiming and value creating. So in terms of value claiming, negotiators often want to get as much value out of the negotiation as they possibly can. And this is done through making ambitious offers. So for example, you want to begin the offers by begin the negotiation by claiming more of the things you want rather than giving those items away to an opponent. You also want to be aware of your BATNA. So your BATNA is the best alternative in the case that this negotiation doesn't work. So for example, if you were negotiating the salary, your BATNA may be another offer that you have. And lastly, to claim value, you want to concede efficiently, so don't just give up everything that you want. And then on the other side, beyond claiming value, negotiators often try to create value. And in order to create value, you must understand what your opponent wants. And in order to do that, you cannot assume that they want the same thing. So oftentimes, there's this bias that negotiators have where they assume they and their opponent want the same thing, and that may not be the case. And so by making trade-offs, we're better able to create value. Next slide. So in the interest of time, I'm going to focus on one aspect of the negotiation of value creation. As I stated, value creation is really about understanding what your opponent wants and then using that information to come to a win-win deal. And there's two common approaches used to generate these models. Is often the frequentist or the Bayesian approach. So the frequentist assumes no prior information about an opponent and estimates a weight based on how frequently someone makes offers that claim certain items. So for example, if you're negotiating a salary and you're harping, if you're negotiating a job offer and you're harping on salary versus vacation time or some other issue, then we assume that that's perhaps is the thing you care about most. Now, in a Bayesian case, the model begins with some prior assumption about what an opponent wants and then uses Bayes rules to update that belief. Next slide. And we can apply these models to the dialogue in a negotiation and essentially use multiple channels of information to build a model of our opponent. So in a negotiation, negotiators often share their preferences through statements. They make offers. And so by using these two channels of information, we can get a sense of what the person wants. So in this case, the agent says they want chairs in place, and it also makes offers for 2 chairs. And so in this case, we get a rough sense of what the agent might care about. Next slide. And so using these models, one of the things we wanted to do was to compare how good they are across a number of scenarios. So assuming that let's say we have, in the Bayesian case, we compared what the performance of a uniform model where we assume that initially the agent wants everything equally, a fixed pi where the agent assumes that they and their opponent want the same thing, and the empirical model, which looks at prior models of negotiators' preferences as a baseline for the model to begin understanding what an opponent wants. And we find that based on the prior information provided, that really dictates how well the Bayesian model performs as opposed to the frequentist. And so we can use these models in a training scenario to diagnose errors that students make. So for example, we find that given the channels of information provided, if we see that the model we generate for the student is inaccurate, then oftentimes the student failed to reveal preferences or reveal inaccurate information about themselves. If we see that the model isn't very good at understanding what the agent wants, then perhaps the student isn't asking as much questions about the agent's preferences. And also, if we find that both the models are correct, but the student isn't doing well, then we see that they're not using the information provided. And so what we find is that these models are, in a learning context, these models do perform just as well as expert students. And so they allow us to diagnose how good students are at modeling their opponent. And so in this case, we see that, for the novices, there's quite a bit of information that's being provided by the model, but they're not doing as well. And so we can use this to help train humans to become better negotiators. Next slide. And two of the agents that we use to build these, two of the systems we use to build these negotiating agents are, one, the conflict resolution agent that uses the virtual human toolkit, and as well as the Iago agent, which is a web-based interface for building these type of work. And so what I've shown is that we can build models that allow us to ascertain what an opponent wants in a negotiation. And in this case, we're looking really at their preference ranking over a set of issues. But in reality, there's a number of features that dictate how well a negotiation proceeds. And so moving forward, one of the things that we want to begin to look at is, how do you improve sort of this common sense reasoning, and how do you get agents to incorporate more common knowledge into the way they negotiate, increase the sophistication of these models, so that it can incorporate other things such as the emotional state and more sophisticated dialogue. And lastly, looking at how these approaches may be generalized to other interpersonal skills, because oftentimes in many of these scenarios, you have humans interacting over a set period of time, and we can begin to build models to help agents better interact with humans. Thank you.
Thanks very much, Emmanuel, and thanks to all our speakers. And now it's time for questions. So we have one question already in the Q&A window. It's for Mayank. So Mayank, can you please say a bit about how you might measure the creativity of the GP3 language model?
Yeah, it's a very interesting question. So there is two ways to think about this. So one is what we call the functional metric. So the idea here would be that, let's say you're given some problem and you come up with a creative solution to the problem, and the solution has utility. Maybe it's very efficient, it solves the problem, and so on. And so it's like grading, right? Like how we grade homeworks, or how we grade applicants to programs, right? And so there are objective metrics. And then the other one is a value judgment, and that's much harder, right? So if I take you to a wine competition and ask you to rate the wines, it's very difficult to be objective, and there's evidence of that. There's aesthetics, there's those kinds of things, more intangible aspects of creativity. So it's what I would say is that, although it hasn't been done yet, we need rubrics. I think we need to agree as a community on rubrics rather than on things that can be quantified, just from some program. So what are the rubrics, right? So what rubrics make sense for what problems? That is what we need to agree on as a first step. And then the second step is that, then it becomes more like an annotation problem, like an IR, right? Is the document relevant to the query? I think that we can score the rubric, but we need to agree on rubrics rather than get stuck in this mindset that, everything has to be computed, in terms of utility. So that's how I would say it. I think it's we haven't done this yet, but that's the way that I think it should be approached, in my view.
Thank you. There's another question. I think this question is for Emmanuel because it's about negotiation. So The question says, I really like the idea of AI negotiating on my behalf, but the other side would have its own counter AI negotiator. How do you resolve the AI to AI negotiation?
I think the idea here is to have an agent that one understands and is able to negotiate effectively on your behalf, regardless of who the other negotiator is. Because even if it's a human negotiator, you assume that they have they are just as expert as you may be. And so in that case, I think the goal is that the agent is better able to, as the agent is better able to model your preferences, and in some cases, it won't accept a deal that's less optimal unless that is the criteria you embed into the system.
I actually have a follow-up question on this. So, Emmanuel, you talked about modeling the opponent's behavior.
Yes.
But I think that is also relevant to Ma Young's work, who talked about novelty, because my understanding is that for both handling novelty and negotiation, you may want an agent to be able to learn on the fly. So regarding modeling the opponent's behavior, what do you do in situations where there isn't enough time to reliably model an opponent? For example, a negotiation task could be very short, which means that the agent won't be able to get enough information to update its model of the environment, of the opponent. So is it better to have an inaccurate model of the opponent or not to use such a model at all? And the reason I'm asking this question is because I've worked on negotiation, and in my previous research with a former student, we found that modeling the opponent hurt because we couldn't do that reliably. So do you have any thoughts?
Yes, so historically, I think what you're pointing to is right, in that much of the work in agent-agent negotiation has shown that the frequentist models tend to outperform Bayesian models. And part of in those scenarios, the agent can assume a number of different models of their preferences. But what we find, and that was what I was presenting in the work with the Bayesian versus frequentist model, is that in some cases, for example, a salary negotiation, there's common models that most humans assume. So in a job negotiation, people tend to prefer salary more than anything else. And so in those cases, we can use empirical priors as a way of addressing the lack of information we may get from an opponent. And so in the human agent negotiations, for example, people don't typically share very much information about themselves, nor do they make a lot of offers. And so by utilizing prior information about what folks tend to do in a negotiation, we can address the lack of information provided.
Yeah, that makes sense. In our case, it was a negotiation about arranging a party, so it was harder to make assumptions about preferences.
Right.
Any other questions? I could ask one more. It's for Fred. So
there's a question.
Ma Young, you have a question? Please go ahead.
Oh, no, there's a question.
Oh, okay, right. Sorry, it just arrived. So can you speak to the possibility of having an agent play the role of facilitator? And this question is for Emmanuel, maybe? Who is this question for? Emmanuel, yes.
So facilitator in what sense?
Okay, facilitator in the sense of trying to engineer cooperation instead of adversarial negotiation. And yes, please talk. Henry, you can talk.
So I think some of the work we've done is, and I think one of the ways that agent can sort of play as a facilitator is the agent can begin the negotiation. For example, what I talked about in the value creation space, what you want to do is really understand what your opponent wants before you make offers or begin that negotiation. So in the beginning, what the agent could do is spend some time really sort of querying an opponent to understand what their interests are, what things they truly care about, and then using that to essentially guide the negotiation. In addition to that, by depending on which model the agent uses, if the agent does not assume a fixed pi bias, meaning that both they and their opponent want the same thing, then they are much likely to try to find these sweet points where both parties walk away with the things they care about most. And so by allowing agents to reason about or the ability to ask questions as well as not assume that fixed pi bias, we can build agents that are better able to facilitate the negotiation.
Yeah, thank you. Can you hear me?
Yes, we can
people hear me.
Yes.
Yeah, okay. Thank you, Manuel. Yeah, so that's precisely it. So the reason you need a facilitator role in a negotiation is if you have an adversarial, I've studied a little bit of the literature on conflict resolution, I'm sure you have as well, if you just have, two adversarial parties and they try to ask, well, what do you want? That it's hard for each of the parties to reveal their true preferences because they might, it might be exploited by the other side. But what a facilitator does also, is the facilitator, if they convince both sides they're neutral, they have separate discussions with each of the sides in order to determine what their real preferences are. And those preferences are not revealed to the other party. Okay. At the same time, what the job the facilitator is doing is trying to figure out, can I intersect those preferences? Since I know both preferences, can I intersect them to find some area of an agreement, which is hard to do for the adversarial parties on their own. So that's the issue.
Okay, so thanks very much, everybody. It's 9:50 it's time to wrap up the session. Thanks very much to everybody, the speakers and the people who contributed to questions. And that's the end of the session, and we'll be back in 10 minutes.